Okay guys, today we're doing 6.2 and it's going to be trig integration and particular solutions. Okay, basically what I'm going to be doing is it's two different lessons. I'm going to teach you how to do particular solutions, that won't take very long, and then I'm going to show you how to do trig integration, which won't take very long either. That's why I've included these two together. They're pretty simple and they're pretty fast. Okay, let's get started. First one here. Let's do particular solutions first. And so here's what a particular solution means. First off, let's take the integral of this. It says find the original equation with the given information. So it's basically asking us to take the integral of this. Because if we take the integral, then we will have the original, right? Since this is the derivative. Okay, so the original is going to be, if we take the integral of this, it boost and divide each term. So 4x squared over 2 minus 5x plus c. Okay, that's the original equation, and if you simplify it, it would look more like this. Okay, now this is an integral. That's how I've shown you how to do it, right? Now a particular solution, which is what the next step asks us to do, is to find the particular solution of f of x, means you're going to find the exact answer that it is. So right now it could be one of infinite answers because c could be any integer or any number there is, right? So what we're going to do is we're going to actually figure out what that number is. Now in order to do that, they're going to have to give you a point on the function, which in this case they said the original function f of x has a point f of 2 equals 10. Find the particular solution. Well, since they give me a point, I can use that point to figure out what c would be, the unique solution to this problem. So since f of x equals 2x squared minus 5x plus c, I can switch in f of x is going to be 10, that's my y value, and instead of x, I'm going to be putting the x value of 2. And then that leaves me with just one unknown variable, and I can solve for that unknown variable. That's going to be 10 equals, okay, this is going to be 4 times 2 is 8 minus 10, which would be negative 2 plus c. Add the 2 over, and c is equal to 12. Now that's not the answer though. The actual solution of the function is the answer. So our answer is actually f of x equals 2x squared minus 5x plus 12. That's my answer. That's the particular solution. Don't just circle c equals 12 and say that's the solution. Okay, let's do another one of these. They're going to give us the derivative. And it says we know the original equation passes through the point 3, negative 1. What is the original equation? They could also write this as what is the particular solution. Okay, and just so you guys see that, I'm going to write that underneath it because that's how they're normally going to ask it. Okay, what is the particular solution? Okay, whenever you see that word, that means find c. Okay, that means find c. So let's take the integral of this. Since the integral would give us our original function, right? That's going to give us the f of x form of it. Okay, term by term, x cubed over 3 minus 2x squared over 2 plus 2x plus c. Okay, that's the integral of that, right? The integral sign and the dx disappeared since I took the integral and the plus c went in its place. Particular solution means that we should have the y and the x in order to find c, which here's my x, here's my y. So negative 1 equals 3 cubed over 3 minus 2, and these 2's cancel, right? So how about I just ignore that and say 3 squared plus 2 times 3 plus c. And just solve for c. So I got negative 1 equals, okay, this is going to be 27 over 3, so this is going to be 9 minus 9 plus 6 plus c. Well, the 9 minus 9 cancel each other out. We're left with negative 1 equals 6 plus c. And c is equal to, subtract the 6 over, 7, negative 7. Okay, so that is not my answer though. My particular solution is my answer, which would be the actual function written out with that there. Okay, this is my original function, x cubed over 3 minus x squared, because those 2's canceled out, plus 2x minus 7. That's what my c is. It's negative 7. And that is the particular solution. And that's the first half of this lesson, how to find the particular solution. If they give you the x and the y, you can figure out the c. That is the particular solution. So let's go forward and I can show you how to do trig integration. Okay, first thing we need to go through is the derivatives, okay? Because if you know the derivatives of these trig functions, then you also know the integral, okay? Because it's just going backwards. So let's start on the left side here. Left side. What is the derivative of sine? Well, it's cosine, right? What's the derivative of cosine? Negative sine, and the derivative of negative sine is negative cosine. And then you go back through it, right? Now the way I showed it to you guys was I did it as a wheel. I did sine, the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of negative sine is negative cosine. And going around in clockwise manner gives you all the derivatives, right? Okay, so going counterclockwise will give you the integrals. The integral of cosine is sine, okay? The integral of sine is negative cosine. The integral of negative cosine is negative sine. The integral of negative sine is cosine. So you can just go counterclockwise to get your integrals. Okay, since you know those, let's go over here to this. What is the derivative of tangent? Derivative of tangent is, derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant tangent. Okay, so whenever they're asking you to do the integral today, okay, it's going to have to fall within one of these 4 things, okay? The integral of each of these is that. So the integral of secant squared is tangent of x. The integral of negative cosecant squared of x is cotangent. The integral of this is that. The integral of this is that. So these are the only integrals of trig functions you know, okay? So you're going to be able to, today you will be able to make any function that I give you look like one of these or sine or negative cosine. Sine, cosine, negative sine, or negative cosine. So it's either going to look like one of these 4, or it's going to look like one of these 4. If it doesn't, that means you're either doing something wrong or you cannot find the integral of it, okay? Because I haven't shown you how. So it's going to look like one of these 4 or one of these 4. So let's go forward and do some of these. Okay, so first thing here, we're going to do the integral of this. First thing is the constant that's with it, it just comes down with it, okay? Now we're going to do the integral of cosine. Well, remember the thing I showed you guys. Okay, the clockwise is like that, that's derivatives. Counterclockwise is integrals. I have cosine, or you could think of it as negative cosine if you did that, but I'm thinking of it as cosine. The integral of cosine is sine. And then plus c, because I got rid of the integral sign and the dx, and that is my original equation. That is the integral of that. Okay, let's do this one. Now it's cosecant squared. That's going to be one of those 4 that I showed you. Let's go back and look at it. Cosecant squared, the integral of cosecant squared is cotangent, but it's really negative cosecant squared, right? So since this doesn't have a negative on it, I'm going to have to make sure that I move that negative over here. So it's going to look like this instead. So if this is positive, that means that this has to be negative. Okay? So the integral of this is, bring the 2 down, and then it's going to be negative cotangent of x, and put plus c. And that's going to be my original on that one. That's the integral. Okay, next one. I think I got 2 slides here for you. Okay, this one here. Now, I don't have my, I can't have things written on the denominator. Okay, I need to move that to the numerator just like I would for anything else, because none of my functions over here have stuff written on the denominator, right? I want to make it look like one of these four or one of these four. If I can't, that means I don't know the integral. So I'm going to move it to the top so I can see if it looks like one of those. So that if you move it to the top, it's going to be 3 secant squared of x dx. Now if you're like, where in the world did the secant come from? Okay, remember, 1 over cosine is the same thing as secant. 1 over sine is the same thing as cosecant. Okay, so I moved this to the top and it became secant. And since it was squared, this is also squared. Now, do I know the integral of secant squared? Well, let's go back and look at this. Yeah, the integral of secant squared is tangent. Okay, so let's rewrite what I had there. It's going to be the integral of 3 secant squared of x dx. The integral of secant squared is tangent. So the 3 comes down and I have tangent of x plus c. And there's my original function. Okay, now I'm going to do the next one here. Now if you notice, we have 2 terms. Remember what I was telling you guys about integrals. You're doing the integrals term by term. Okay, so this one right here is not a trig one. That's just going to be regular boost and divide. So it's going to be 4x squared over 2. Yeah, that boost and divide. This is a trig function. So this, the integral of sine, well, let's see here. I'm going to write my circle here. Okay, the integral of sine, which is counterclockwise because we're doing integrals, would be negative cosine. So it's going to be minus 7 cosine of x. Now notice I have the minus in the front of the 7, okay? That's fine. It was because it was negative cosine, and I didn't want to put the minus in between here because it would have looked like 7 minus cosine. And then since we did the integral already, we're going to put a plus c at the end. And there's my answer right there. Now I could have simplified this a little bit more, so it should really look like this. Okay, there's the simplified answer. Okay, and that's how you do the integral. Okay, now I got one more here. Okay, if you look at this, this looks complicated. This does not look anything like any of these 4 on the right-hand side or any of these 4. So what I'm going to have to do is I'm going to have to manipulate it to make it look like one of those. If I can't, then I just don't know the answer, okay? So, one trig identity, which is this is the trig identity you should have memorized from pre-cal. It's the most important trig identity, in my opinion, for the calculus course. Sine squared plus cosine squared is equal to 1. So that means you can move one of these over, kind of like how I have 1 minus cosine squared. Let's move the cosine squared over it by subtracting it. So that means that sine squared is equal to 1 minus cosine squared. Now, notice you could have moved the sine squared over and it would be the same thing. Cosine squared is equal to 1 minus sine squared. So these are 3 things you need to know. If you see the sine squared plus cosine squared, that's 1. If you see 1 minus cosine squared, that's sine squared. If you see 1 minus sine squared, that's cosine squared. In this case, I have 1 minus cosine squared, which is the same as sine squared. So I have the integral of cosine of x all over sine squared of x dx. Okay, now I am manipulating this to make it look similar to one of those 4 functions I had, okay? Now, there's a lot of ways to manipulate this. So how about I take an incorrect route first, okay? So this is going to be wrong. I'm going to move this sine to the top. And remember, 1 over sine is the same as cosecant, right? So if I move that to the top, I can have the integral of cosine of x, cosecant, because I'm moving it to the top, squared of x dx. Okay, is that the same as one of those 4 functions? Now I don't want to go back on the slides because then I erase all this work I do. But if you look at those 4 functions I showed you on the last slide, this is not an integral you know, okay? So at this point I would say, okay, I manipulated it incorrectly. I don't like this route. Let's try a different route. Okay, another route I could have gone is I could have written it as cosine of x over, now I have sine squared means sine times sine, right? So how about I separate this to be sine of x times 1 over sine of x dx. Okay, now I know this is something that you guys probably wouldn't have recognized, but I'm showing it to you now, so now you know that this is a route you can go. Okay, cosine over sine, that is the same as cotangent, right? And then 1 over sine, I already told you guys, is the same as cosecant. Okay, and that we do know the answer of. Remember, the derivative of cosecant, if you're taking the derivative of this, derivative of cosecant of x is equal to negative cosecant of x times cotangent of x. That's one of the rules you guys know from that PowerPoint if you look at the stuff you have written down. So I know the integral of cotangent times cosecant, which I have here, is cosecant. Except here I have a minus here, right? And I don't have a minus here. So that means that's no big deal. I can just switch the negative sign onto the other side. So the integral of this is equal to that. So it'll be negative cosecant of x plus c. And that's the answer. Okay, and that's everything I got for you guys. Good luck on the worksheet. And remember to manipulate as best as you can, okay? If you manipulate in the incorrect way, that's fine, okay? I would have done that back in the day too. After you do a whole bunch of them, you'll just start seeing the route you're supposed to go, okay? And I know that's going to take time and practice, but that's why you have a bunch of problems to do on the worksheet to help you with that time and practice.